Okay, so you're interested in quantum computing, and let's face it, who isn't?
Right.
But what if I told you we're on the brink of a huge breakthrough?
Huge.
Something that could push quantum computing beyond what we even thought possible.
That's right.
Like way beyond.
We're diving into an MIT research paper that proposes a whole new way to create qubits.
Wow.
The building blocks of quantum computers.
Okay.
And this isn't just a minor tweak.
Got it.
It involves something called non-Abelian anyons.
Non-Abelian anyons.
A type of exotic matter.
Exotic matter.
Yeah.
Sounds intense.
It is.
I'm guessing this is going to get pretty complicated.
It can be. But stay with me.
Okay.
Imagine you have an electron.
Okay.
A fundamental particle, right?
Yeah.
Now imagine that electron could split into fractions.
What?
Each with a unique set of properties.
Okay.
That's the bizarre world of electron fractionalization.
So it's not like cutting an electron in half and getting two smaller pieces.
Not at all.
Okay.
It's more like splitting a wave function.
Okay.
Creating multiple entangled states of the same electron. It's a quantum phenomenon that defies our everyday intuition.
You've definitely lost me with the wave function talk.
I figured as much.
But I'm intrigued. So how does this electron splitting connect to these anyons and quantum computing?
Those fractions,
those
entangled states, are what we call anyons.
Okay.
They're these quasi-particles with a fractional charge. And get this, a kind of memory of their past paths.
Memory?
Yeah.
Like they remember where they've been?
Right.
How is that even possible?
It's a mind-bending concept, I know.
Yeah.
But think about it.
Okay.
If we can harness that memory, we can create qubits that are not just a 0 or a 1, but can exist in multiple states simultaneously.
I see.
And they remember each state they've been in.
Whoa. So it's not just about the current state?
Nope.
But the entire journey of the anyons?
The entire journey.
That sounds incredibly powerful for computation.
It is.
Yeah.
And this brings us to the heart of this MIT research.
Okay.
They've proposed a way to create and manipulate these non-Abelian anyons.
Okay.
Specifically for use in quantum computers.
So they're not just theorizing about anyons. They're saying we can actually build them.
That's the exciting part.
Wow.
Their proposal involves using what are called moire materials.
Moire materials.
Which are basically stacks of 2D materials.
Okay.
Like molybdenum ditelluride.
So it's like building a microscopic Lego structure with these 2D materials. What makes them so special for creating anyons?
It's all about the precise arrangement of these layers.
Okay.
By stacking and twisting them just right, you create an environment where electron fractionalization can occur, and these non-Abelian anyons can emerge.
I see.
The 2D nature of the materials is crucial.
Got it.
Because it provides the confinement needed for these exotic particles to exist.
Okay, so we have these special 2D materials. We stack and twist them like microscopic Legos.
Yeah.
And boom, we have the potential to create these non-Abelian anyons with their incredible memory.
Right.
Sounds almost too good to be true.
There are certainly challenges.
Okay.
But the researchers have laid out specific conditions and theoretical calculations that suggest it's possible. They've essentially created a recipe for cooking up these exotic particles.
A recipe for exotic particles.
Yep.
Now, that's something I never thought I'd hear.
Right.
But before we dive into the specifics of this recipe, why don't we take a moment to explore what this breakthrough could actually mean for the future of quantum computing?
Absolutely. Let's shift gears and talk about the potential implications of this research.
Okay.
Yeah.
So we've got these non-Abelian anyons, these rule-breaking particles with a memory potentially brewing in these moire materials.
Right.
But what's the big deal? Why should we be excited about this?
Right.
Beyond the cool factor of exotic particles.
It's about more than just cool factor.
Okay.
Although that certainly plays a role.
Sure.
The potential impact on quantum computing could be revolutionary.
Okay.
Imagine a quantum computer that's not only more powerful, but also inherently more stable.
Okay.
Thanks to the unique properties of these anyons.
Okay, paint me a picture. What could we actually do with these super-powered, stable quantum computers?
Let's start with medicine.
Okay.
Imagine being able to design drugs at the molecular level.
Wow.
Targeting diseases with unprecedented precision or simulating complex biological processes to understand how diseases develop and how to prevent them.
Wow, that's incredible.
It is.
It's like having a virtual laboratory inside a computer.
Exactly.
What else?
Think about material science. We could design entirely new materials with properties we can only dream of today.
Really?
Materials that are lighter, stronger,
Yeah.
more conductive, even self-healing.
Wow.
This could revolutionize industries.
Yeah.
From aerospace to energy to construction.
Okay, so I've got revolutionary drugs and super materials. Anything else on the horizon?
Let's not forget artificial intelligence.
Oh, right. AI.
Quantum computers powered by non-Abelian anions
Yeah.
could enable AI algorithms
Uh-huh.
that can learn and adapt
Right.
at an unprecedented rate,
Okay.
possibly even surpassing human capabilities in certain areas.
That's both exciting and a little bit terrifying.
I agree.
It sounds like we're talking about a whole new era of technological advancement, all thanks to these tiny, exotic particles.
It's certainly a possibility.
Wow.
And as physicist Bahua Zhang pointed out in their comments on the research, you might be just scratching the surface of something truly profound. They urged us to consider whether our current understanding of physics is sufficient to truly grasp the nature of these anions.
They were questioning whether our mathematical models are up to the task.
Essentially, yes.
That's pretty thought-provoking.
It is.
Yeah.
Zhang also highlighted the fascinating connection between these anions and space-time.
Okay.
The fact that they can only exist in these 2D materials raises some deep questions about the nature of reality itself.
So it's not just about building better quantum computers. It's about expanding our understanding of the universe.
Absolutely.
I see.
Zhang's comments remind us that science is not just about practical applications.
Okay.
It's also about pushing the boundaries of human knowledge.
Right.
And challenging our assumptions about how the world works.
I'm also curious about Zhang's comment about not confusing appearances with essence.
Yeah.
What do you think they meant by that?
They were cautioning against jumping to conclusions based solely on what we observe in experiments.
I see.
The behavior of these anions in these specific conditions might be fascinating, but that doesn't mean we fully understand their true nature or potential.
So there's a lot more to discover.
Oh, yeah.
Even beyond the remarkable properties we're already seeing.
There's always more to learn.
Right.
And that's what makes this research so exciting.
Yeah.
We're on the verge of unlocking a whole new realm of possibilities.
Wow.
Both in terms of technology and our understanding of the fundamental laws of the universe.
It's amazing to think that something as tiny as a non-Abelian anion could have such a massive impact.
Yeah.
But it makes me wonder, how does something like this even get discovered?
That's the beauty of science.
Yeah.
Driven by curiosity and this constant urge to understand how things work.
Yeah.
Even at the most fundamental levels. Someone stumbles upon an anomaly.
Right.
Something that doesn't quite fit. And boom, a whole new field of inquiry.
And in this case, that anomaly leads us to these exotic particles that could revolutionize everything.
We really could.
From medicine to AI.
Yeah.
It's mind-boggling. But I have to admit, it all feels a bit abstract. I'm trying to wrap my head around what this actually means for me, for someone who isn't a scientist or a tech whiz.
It's fair to wonder how these advancements will trickle down to our everyday lives.
Exactly.
Let's bring it back to you.
Okay.
What are you passionate about?
Okay.
What problems do you see in the world that you wish could be solved?
Well, I'm definitely passionate about healthcare.
Okay.
My family has a history of certain diseases.
Right.
And I've always been interested in finding ways to improve diagnosis and treatment.
That's a perfect example.
Yeah.
With stable and powerful quantum computers, we could potentially simulate complex biological processes at a level of detail never before imagined.
Really?
Imagine being able to pinpoint the exact genetic mutations that contribute to your family's predisposition to those diseases or developing personalized therapies tailored to your specific genetic makeup.
That would be game-changing.
For what?
And it's not just about healthcare.
Right? No.
This could impact pretty much every field.
Absolutely.
Like if you were passionate about sustainability and finding solutions to the climate crisis.
For example, quantum computers could help us design new energy storage systems that are more efficient and sustainable.
Okay.
Or create catalysts that can capture carbon from the atmosphere, mitigating the effects of climate change.
It's incredible to think about the possibilities.
It is.
But as we've discussed, this research is still in its early stages.
It is.
There are challenges to overcome before we see these quantum computers in action.
Of course.
Yeah.
There's always a gap between theoretical predictions and practical implementation.
Right.
But the fact that we're even having this conversation, that we're exploring the potential of these exotic particles, is a testament to the ingenuity and persistence of the scientific community.
Absolutely. And as Zhang's comments reminded us, it's not just about the technology itself.
Right.
It's about expanding our understanding of the universe.
That's right.
Maybe these Xenions are just the tip of the iceberg.
Maybe.
A glimpse into a whole new realm of possibilities that we haven't even imagined yet.
It's very possible.
That's a really thought-provoking idea.
It is.
And perhaps the most important takeaway from all of this is the power of curiosity. It's what drives scientific progress. And it's what will ultimately lead us to those groundbreaking discoveries that shape the future.
Couldn't agree more.
So to all our listeners out there, keep asking questions, keep exploring, and never stop wondering about the mysteries of the universe.
The universe is a strange place.
Who knows what we'll discover next?
Until next time, keep diving deep.